Good morning and good evening or good lunch, everyone. My name is Britta Scheck, and I'm product manager for Altair's solution for perceived quality, which includes the Squeak and Rattle director. Today, we'll mainly focus on the highlights in Squeak and Rattle director in the latest release 2022.2, but I'll also start with a short overview of the solution in general. SnRD, as I mentioned, which is part of the solution for perceived quality, has one main purpose, and that is to eliminate the squeak and rattle issues through simulation. These issues are all very much unwanted noises, and they occur because of when multiple parts interact with each other under vibration loads. And these are one of the primary causes of lack of perceived quality in the industry, which is not relevant in the automotive. It's across electronics and aerospace and many other industries as well. Traditionally, these issues are fixed based on iterative physical testing, which is often done at later phases of the product development. And as you can imagine, it ends up in very expensive reworks and quick fixes at the production stage. Through simulation, we can eliminate most of these issues and even before the first prototype is built. Altair's solution for this is well established and has over the year become industry standard for Squeak and Rattle simulation. So Squeak and Rattle issues is, as we've seen, a responsibility of many at every stage of the vehicle development cycle or product development. Even at the early design stage. So here we provide the tools and technology for the first stakeholders, designers, allowing them to evaluate the risks very quick and iteratively. And this is achieved using CAD Based simulation combined with material compatibility analysis using Ziegler stick slip material database, which I'll get to a little bit more later in the presentation. As soon as the first finite element model is available, we can then add on and perform a structural squeak and rattle risk analysis, which allows us to identify the issues utilizing solutions like SnRD, and which is leveraging the industry standard E-line method. Here, we also leverage structural optimization in different ways throughout the entire development process to guide us in the right direction on how to actually solve the issues that we find. One can also include variabilities in the model through a DOE and stochastic study, and this allows us to examine how the squeak and rattle risk will directly be affected by variations caused by manufacturing, external effects, or wear. One can also correlate with tests with the main purpose to improve the quality of the virtual testing. Our solution is mainly about providing the simulation tools, but we can also at this stage help out with physical testing through our partners, which we've done in many projects. So if you look at that entire solution, it's actually not only Squeak and Rattle director. It's built up of various Altair applications, and including our partner Ziegler's methods. But key component of it is, of course, the Squeak and Rattle director, which we're here for today, and the Ziegler PAM or Ziegler stick slip database, which is leveraged in different ways across all of the vehicle development process here. You can see. So the Ziegler material database provides over 11,000 test results from stick slip tests performed by Ziegler instruments. And with this data, one can easily compare and assess the compatibility of different materials through metrics such as the risk priority number and impulse rate. And it is now available now at Altair Material Data Center, which I'll get to later. We also have a direct integration of this database inside of Squeak and Rattle Director, as we need the impulse rate of a material pair, as we use that as a criteria to evaluate the squeak risks. And the Squeak and Rattle director, which I mentioned, for those of you who don't know, it provides a streamlined, intuitive workflow to perform a Squeak and Rattle risk assessment, as well as providing more advanced diagnosis tools, which makes it easy to identify the root causes of the issues, as well as finding more optimal solution to actually eliminate them. But how does it work? What technologies that we use in Squeak and Rattle director? So to detect both Rattle and Squeak, to make it very simple, we actually track the relative displacement in all direction between two components. For Rattle, we keep track of the movement in the gap direction, and we compare that movement with the nominal gap, which we extract from the drawings and the GD&T data. If the relative displacement is higher than the gap, then we know we have a risk, as you can see here. A squeak is an issue caused by friction. So here we track the movement in the contact plane, and the risk is evaluated based on the frictional parameters of the interface. And this is where you can use the Ziegler stick slip database. So now that we know what it is, how do we access it? Since 2021, Squeak and Rattle Director has been integrated in HyperWorks, so no separate installer needed. The Squeak and Rattle Director tab is disabled by default, so to access it, you just enable the ribbon tab through the View dropdown. An additional license will be drawn when SnRD ribbon is visualized and active. So it draws an additional 19 units. And the more advanced post-processing and diagnosis capabilities that I mentioned can also be accessed. And to access these, you need to load through a sessions file. And we are working on making this more easily accessible too. So now over to the main event, which is the highlights for the latest 2022 release solution. I'll start with the most major one, I would say. There has been a drastic need to improve performance of the creation of the E-lines that allows us to track the relative displacement. And this was especially true for large models. And we've also gotten many requests to give more control over the actual realization of the E-lines to ensure that E-lines are created properly in all areas of interest. Previously, as an example, when an E-line failed, one could not really see why it failed, and one can also not find a solution for it. So here we leveraged core connector control functionality, which have allowed us to both drastically improve the performance. You can see we have or even more sometimes, but for this example, a 5 times faster speed up. But it's also made the creation much more robust. And the workflow, as you can see, has not changed much, but one can easily access the connector controls and modify the E-lines to ensure you get the behavior that you're after. Right, guys? So we've also made some changes to the risk assessment, which allows you now to review the results directly on the model in HyperMesh. This reduces a few steps, which sometimes are very time consuming, like having to reload the model. And it also enables you to modify the model directly based on the results. One can still review and compare results from multiple load cases, as you can see here. But once you're done with your result evaluation, you just basically just turn off the results so you can continue modifying the model. No need to work in different sessions as previously. Oh yes, and we have also made it more streamlined to change the point of the E-size, change the size of the E-points, which has also been a big request. So once you've actually then reviewed your results in the risk assessment, you can now create a summary report in PowerPoint, which gives you an overview of all the results and all load cases that you have active in the session in just a single click. And both the contents of the report as well as the template that's being used to create the report can be configured. And some very big news, which I did previously mention, is that we have now fully migrated the mentioned Ziegler database to Altair Material Data Center, making it fully accessible in the cloud. This new interface offers much more flexibility, as one can now filter and sort on all available parameters, something which has been requested by most users. Lets you perform the compatibility analysis much easier. So let's take a closer look at how this works. So the database contains those 11,000 stick slip tests, as I mentioned. So you start by selecting the materials that you want to include in your analysis or compatibility analysis. And you can see that you can select both, material, manufacturer, and brand here. And when you're selecting the, obviously, it's filtered based on your selection. And the risk priority number is a criteria to show which material pair show a high risk for Squeak for that specific test. So you can filter based off of this number to get an idea of how many tests are actually high risk. And you can also look at the impulse rate, which gives you the number of stick slip transition per millimeter, which is something that we use directly in our Squeak and Rattle simulations. And if you want more detailed information on every single test, what all the circumstances were and all the parameters, you have that available too. And reviewing all the material pairs list that you can customize, make it very, very flexible, and you can compare based off of all available parameters. And obviously sort on them too, if that's required. So like I mentioned, this is now available on Altair Material Data Center. There is or will be an entry point from the starting page, and you will need AMDC licenses or full access to AMDC to be able to access this. Another very big exciting news is that we now have basically the first step towards being able to do CAD based Squeak and Rattle prevention. SimSolid have introduced a new tool in the post-processing, which allows for tracking of relative displacement between two parts at multiple locations. As of now, it only supports for linear static, which allows you to evaluate load cases such as quality feel or leaning against headrest. But the plan is also to support modal transient load cases in the future. So let's take a look at this tool too. So this simple model that you can see here, let's just review it first. It's being pulled up in the positive directions. Basically, all of these parts are being pulled apart. The plates, as you can see, are separated with an initial gap, which is automatically extracted from the model, which is one of the main benefits of working directly on CAD instead of FE. After reviewing the static analysis result here, we want to see which potential areas now show a risk for Squeak and Rattle. So we go to the pick info and the relative displacement tab. So this is the new tab. And here you can pick any point to see the final status of it. So it allows you to see the relative displacement in the gap direction, as well as in the plane. But it also lets you see if the relative displacement caused the gap to close or not. So you can see final status, open, close, overlap there. And you can also see if it actually showed a risk for Rattle or Squeak here. And these evaluation criteria that you can see, the final status of open, close, or stick slip are all based on the failure criteria, which you can modify. So points of interest can be selected manually or directly from these predefined data points. And these data points can easily be imported from a CSV file, so in bulk. So if you already have coordinates of all the areas that you want to investigate. So with that, there we go. So with that, I conclude all of these new, brand new features and functionalities. And just to finish off, I highly, for everyone who is already working with Squeak and Rattle Director, I highly motivate you now to move over to this latest release, mainly because of the major performance improvements that we've done. It's going to save you a lot of time. So until next time, thank you all. And if you want to learn more, you can find a lot of webinars and customer testimonials and other resources on our webpage. Thank you, everyone.